Hey guys, it's Christian, and today I'm going to show you how to solve rational inequalities. So you guys may already be familiar with rational equations, where you have an x on the denominator in some way, and you try to get everything over to one side and set it equal to 0. And there's a couple ways, usually more than one, that you can get the whole thing to be equal to 0. For example, if you set x right here equal to -5, and that makes this section 0, which multiplies to this, and then that whatever this is, that'll still get you 0, and the denominator doesn't matter, as long as it's not one of the excluded values, such as -3, which would give you 0, you can't divide by 0, or a +4, which is the same thing. However, inequalities are a little different. You're going to get more than just a couple specific answers, because for the equations that you're setting equal to 0, it has to be a very specific -5 that makes this whole thing equal to 0. If you plug in -4.999 or -5.0001, that'll get you with something that's not a 0. So it's usually like very specific values. For example, in this case, it'd be a -5 and a +1 that give you an answer to the solution, to 0. But what if you change it, for example, to this? Then you're not just looking for 0, and you're not limited to a specific value, because there are several cases where this whole thing may be bigger than 0, and there's not a specific value it has to equal. It just needs to be greater than 0 or positive. For example, say we plug in +5. That'll make this down here a positive, +8. This down here a +1. This up here a +4. And this up here a +10. So because all of these are positive values, we know that it's going to be above 0, so this section of the inequality would be true, and that also applies, for example, for 5.1, the same would be true, or 5.2. So for inequalities, the solution set, rather than being a very specific set of numbers, is instead like a range of numbers, depending on what these factors are. So the 3 steps to solving rational inequalities are: first, factoring and getting everything equal to 0. So getting all the variables on one side in one fraction and having that whole thing be equal to 0. Or in the case of an inequality, maybe be less than or greater than equal, or less than or equal, and so on. But just to have everything on one side and 0 on the other side. And then step 2 is to find critical points. For example, once you've factored and you have everything equal to 0, you have x plus 3, and then maybe x minus 2 squared, or something like that. The critical points would be x equals 0, because that's how this x makes the whole expression equal to 0. X equals -3, because that's how you would make that factor equal to 0 and make the whole thing 0. And the reason that these 2 points are of importance to us in inequalities is because when you have everything equal to 0, you're looking for, all right, is a number I plug into my expression going to make this positive or negative? Because if it's positive, it's going to be greater than 0, and if it's negative, it's going to be less than 0. And the reason we call these critical points is because this is right at the edge where it's going to change between positive and negative. Because at 0, this is going to be right at the tipping point where it equals 0. However, if we plug in 0.1, then that factor would be positive, and if we plug in -0.1, then it's negative. So 0 is just right on that tipping edge between whether this factor right here becomes positive or negative, which becomes important for the sign chart, as you'll see in just a second. And then this down here is also a critical point in its own sense, that this is what x cannot equal. So x cannot be 2, because if you plug in a 2, then you divide by 0, and you can't divide by 0. And then the last step is the sign chart. So the sign chart is the only part of this step process that's any different from solving rational equations. Because usually in a rational equation, you just factor everything and get everything to 0, and then find the critical points to find where your solutions are, and then there you're done, you have your values, and you stop. But here, because you're not just looking for right at where it might equal 0, but also greater than or less than, you have to do this last step. And for a sign chart, you make a little number line, and you put your critical points on it. Let's pretend that this expression had to be greater than or equal to 0. Then, because it's greater than or equal to 0, that means when one of these factors up top is equal to 0, that's allowed to be included as a solution. For example, plug in 0 with a closed circle here, -3 with a closed circle here, and 2 with an open circle, because no matter what, we can't plug in 2 because then we would divide by 0, but you can't do that. But these, you're allowed to get 0, because if you plug in 0, this whole top, the numerator, is equal to 0, and this expression says that this expression can be greater than or equal to 0, and the or equal to part is what allows us to have the closed circles. However, if it was the same expression but just greater than 0, then these points would have to be open circles, because taking that same example again, if we plug in 0, the whole expression equals 0, and 0 is not greater than 0. 0 is equal to 0, so these points cannot be included in our solution. The next part of doing a sign chart is plugging in values here at points outside or inside of the critical points. So for example, we know that -3 is a critical point, so we want to find if to the left of it, or anything less than -3, if that gives us something that is greater than 0 or not. So let's take -5, for example. You plug that in down here, you get -7 squared, which is a positive. We'll represent that just with a plus. And then up here, -5, which is a negative. So negative times -5, another negative. So you have two negatives there. You have two negatives multiplied together divided by a positive, which gives you a positive. So everything to the left of 3 gives you a value that is greater than 0, so you would shade that in to mark that you're including that in your solutions. Now, as I was saying earlier with the critical points, the solutions to where that equals 0 is right at the tipping point to where any number plugged in would either give you a positive or negative answer for a specific factor. So for example here, anything less than -3 plugged in to the x plus 3 factor would give you a negative, but anything greater than it will give you a positive. And let me show you why that matters. Between here, for this point, we're going to see if we can also include that like we did for the numbers to the left of the -3. So let's pick a -1. That's between -3 and 0. So we plug in a -1 here. This bottom factor will always give us a positive because it's squared. So we'll do positive. And then for the numerator, -1, we have a negative. And then -1 plus 3 is 2, so that's positive. So as you can see from anything to the left of -3 compared to anything to the right, anything to the left of -3 made that factor negative, and now that we're to the right of it, it's positive, which changes the whole definition of what we can include in the inequality, because now this whole thing is a negative, because a negative times a positive divided by a positive is a negative, which is not greater than 0, so we cannot include that in our answer. Alright, now let's test our next two zones of our inequality to see what we can include in our answer. Next, we have to test a number between 0 and 2. Anything in this zone will give us the same answer, either negative or positive, so we can pick any number, just whichever is easiest to us. I'm going to pick 1. So we have up top, we have 1, so that's a positive, times 4, that's also a positive, divided by, we already determined that the bottom is always going to be a positive because it's squared. So this would be positive, so this section here between 0 and 2 is going to be greater than 0. So we can shade that in. And then, last but not least, we have anything greater than 2. And I'm going to predict that this will also be allowed to be in our answer, because even though 2 is a critical point to where if we plug in negative 1.9, or sorry, excuse me, positive 1.9, we'd get a negative, but if we plugged in positive 2.1, we would get a positive. However, this doesn't matter because the whole thing's squared. Even if we get a negative or a positive out of it, it'll always come out positive. So let's check just to make sure. If we plug in, say, 5, which is greater than 2, we get 5 from the x, which is a positive, times 8, which is also a positive, over a positive. So that would also be greater than 0 over here. So don't be deceived, even though most of the time between the critical points it switches off between what's allowed to be included in the solution and what's not. There are some cases where there will be a kind of a continuity from one critical point to another. Alright, so let's look at a slightly more complicated example. This one's a little harder than the last one because we don't have a squared in here, so we're going to have to test more things in our sign chart rather than automatically assume that, for example, the denominator is going to be positive. And also, as you can see, this is not set equal to 0 yet, so we need to make that happen. And on top of that, while doing that, these don't have a common denominator, so it's going to be, we're going to have to create a common denominator and multiply out factors. Let me show you what I mean. So, first of all, there's a negative on each side. I think it would be easier to look at if we just saw that as a positive. So we could multiply each side by negative 1. However, there's a rule with inequalities that if you multiply by a negative number to both sides, you have to flip which way the sign is going. So even though we are allowed to now rewrite this as a positive 10 over x minus 4 and a positive 11 over x minus 5, we need to flip the sign now. Okay, now that we have that covered, let's try to get all of this to one side. So first of all, let's just subtract from this side. Subtract 11x minus 5 from both sides. And you get 10 over x minus 4 minus 11 over x minus 5 greater than, or is less than 0, excuse me. Now, this would be pretty difficult to test in a sign chart, so let's try to get it all on one fraction. In order to do that, we need to multiply this whole fraction by x minus 5, and then this whole fraction by x minus 4. So once you do that, you get 10x minus 50 over x minus 4, x minus 5, minus 11x minus 44 over the same denominator. And all of that should be less than 0. And then if we combine the numerators, we'll get negative x minus 94, or excuse me, negative minus negative would be added. So it would be negative 50 plus 44 is negative 6 over x minus 5 times x minus 4. And I think that'd be easier to look at if we factored out negative up here and just negative x plus 6 over x minus 5 x minus 4. Alright, so for step 2, we need to determine our critical points, which now that we've solved it out, we can do. Our critical points from the numerator is going to be x is negative 6, and from the denominator, x cannot be 4 or 5. Alright, now that we have these critical points and we have everything on one side, we go to our last step, which is a sign chart. And make the little number line here. And then we have negative 6 over here, which is an open circle because x is not allowed to equal 0. It has to be less than that. So we'll have negative 6. And then over here, also open circles because you can't divide by 0. You have 4 and 5. So if you plug in negative 6 into our expression down here, you get, or excuse me, you have to plug something below negative 6 in, so negative 7. You get negative 1 times a negative, it's going to be positive up top, divided by negative 7. There's negative 12 and negative 11, so that's going to be 2 negatives, and that's overall going to be a positive. So this is going to be greater than 0, but we're looking for what's less than 0, so we have to exclude everything to the left of this negative 6. Now, for the zone in between negative 6 and 4, I'm going to pick 0 as the point that I want to test. So, you plug in 0, you get 6 times negative 1, which is a negative, over 2 negatives, so the denominator is going to be a positive number, but the numerator is going to be negative, so it's overall going to be negative. And that's what we're looking for. So I'm going to shade this in. Then the next point we want to test is between 4 and 5. We'll pick 4.5. Again, we have a negative up top in the denominator, and then 4.5 on the bottom. You have a negative for the x minus 5, but a positive for the x minus 4, and that gives you an overall net positive, which, like we said, we want it to be less than 0. So that portion would also be excluded. And then last but not least, we're going to test something bigger than a 5. Let's go with 6. You have a negative up top when you plug in a 6. So you have negative over a positive times a positive, which is going to give you a negative. So that would be less than 0, which is what we're looking for. So we would shade this section in. And a lot of the times you'll see solutions not left as a sign chart, but rather almost written like a domain. So in this case, our final answer would look something like this. You have a parenthesis because this negative 6 isn't included, but that's where the solution set starts. You have negative 6, comma, 4, also a parenthesis because the 4 is not included, but that's where it ends. Union 5 with a parenthesis for the same reason as the last two, comma, infinity. And there you have it. That's your final answer, and that's how you solve rational inequalities.